So to get started in Module 1, I wanted to start talking about the players that are involved with hormone balance. So understanding some of these key systems and the relationship to hormones is the best place to start. And it's going to help with some of the hormone interconnections. This will be the key to understanding protocols, because if you can understand the interconnections, you'll understand why different areas have to be supported in order to achieve hormone balance. And your protocols must function kind of like a conductor conducting an orchestra. You have to look at all these players that are involved. There's obviously going to be some that are more important than others, but you're going to have to choose what you put in your protocol so that there is something for all of these players. So who are the players? The liver, the thyroid, the pancreas, the reproductive system, the hypothalamus, the pituitary, the pineal gland, gut bacteria, the adrenals, of course, and the digestive system. So you can see you've got quite a number of them here. Some of them play more of a role than others, but they all need to be considered. The liver, the adrenals, the thyroid, and the pancreas, along with the gut, are the major players. The reproductive system, pituitary, hypothalamus, pineal, and digestive system are actually secondary players, and they're kind of at the mercy of the major players. So a lot of times problems in these areas aren't with them specifically as much as they are a problem with another area, like the adrenals, for example, affecting the hypothalamus. And this is true with other hormones in the body as well. There's many more hormones than you could possibly imagine. Everything works in our body with a signal from some kind of hormone. But we're going to stick with the major ones because that is what we have the most information about. And when you deal with the systems in the body that are responsible for those hormones and you balance those, you tend to balance the hormones as well. So the major players even exert pressure on each other. So the liver can affect the adrenals and the adrenals can affect the liver. So let's start with the liver. It's a gland consisting of a left and right lobe with the gallbladder sitting underneath it. Its main functions is to filter blood from the digestive tract, detoxifies toxins, chemicals, and drugs. It makes bile and controls the secretion into the intestines. So even though the gallbladder is where you store bile, the signal for the bile to be utilized comes from the liver. It regulates the supply and production of glucose and glycogen. It manufactures special proteins involved with transporting substances in the blood, helps with blood clotting, and other things that help fight infection. It helps regulate metabolism, converting T4 to T3, but the kidneys, gut, and the muscles also do this as well. As a matter of fact, most T3 is provided to the body in other areas other than the thyroid. The liver is also involved with production and storage of fat, and it converts nutrients from our diet into substances we need, stores them, and supplies the cells when needed. So what's the hormone role for the liver? It regulates the balance of sex hormones, thyroid hormones, adrenal hormones like cortisol and cortisone. It produces and regulates cholesterol needed to make steroid hormones such as testosterone, estrogen, progesterone, and cortisol. It is obviously a detoxification organ, or gland I should say, and that's not just chemicals and drugs, it's also sex hormones if we have too much estrogen, testosterone, etc., or too much cortisol, and of course the xenoestrogens, which could be pesticide residues or the bisphenol A that's in plastics. So anything like that, the liver it's its job. Basically, if the body doesn't need it, it wants to get rid of it. If it had its way, it would get rid of everything we don't need all the time, every day. So this is phase 1 and phase 2 liver detoxification, and this is the main way that we detoxify chemicals, whether they're man-made chemicals we've ingested, whether they're excess hormones, or whether they're some kind of chemical byproduct that is part of normal function of body, but it's a waste material and it needs to be eliminated. So you have basically the fat-soluble toxins are what need to go through phase 1 and phase 2 so that they can become water soluble. That's all phase 1 and phase 2 is about, changing a fat soluble toxin to a water soluble toxin. And in the middle is a bunch of chemistry. It's not all that important. If you want to learn about all of these, you may. But essentially what happens is you've got this family, the cytochrome P450 enzymes, and what they do is they turn the toxin into something that is reactive so that phase 2 can donate a molecule that will stabilize it. And in the process of what it donates, it turns it from fat soluble to water soluble. All of these processes need nutrients. And this is just a small snapshot of nutrients that are needed. Once this phase 1 and phase 2 is complete, you have something now called a conjugate. For example, estrogen would be E-glucuronide if it went through glucuronidation. And that's called a conjugate. So the E stands for estrogen, and the glucuronide is what glucuronidation donated to the estrogen molecule as part of phase 1 and phase 2. And then it's attached to bile, and it's going to be eliminated either through urine or stool. So that's basically how we detox. This is just a snapshot of the nutrients, but the big takeaway here is that a whole food diet is what the liver needs to make sure it has lots of nutrients for phase 1 and phase 2. So as long as you can understand that a fat-soluble toxin must be converted to water-soluble, and that that's the only way it'll be excreted, then you get the purpose of phase 1 and phase 2. And the decision to detox the toxin should occur as needed. This means nutrients needed to detox must always be there. You know, this idea that you go on a detox twice a year is maybe fun for some people, but in essence, it doesn't make the liver happy. The liver's happy if it can detox every single day. Cytochrome P450 enzymes are made ahead of time and will be waiting when the toxin arrives in the liver. So the problem is if the liver's never encountered the toxin or it doesn't recognize it, then it may take time for phase 1 and phase 2 to occur because it's got to respond to this new toxin. This is why people who drink coffee all the time detox out caffeine quickly. They process and utilize it quickly, whereas someone who never drinks a coffee can have one in, 4 o'clock in the afternoon and be wide awake at midnight. The liver's trying to catch up. When you drink alcohol, you need to remember that the liver detoxes that out right away. So when you have your blood levels measured, it's because it hasn't made it to the liver. When you get pulled over and they want to have you determine if you've had too much to drink, they're measuring the blood. So for alcohol, it comes in, it goes out. And if you've ever, I'm not saying you ever have, but if you've ever had too much to drink, or you know someone who's had too much to drink and they still seem drunk the next morning, it's because the liver hasn't caught up yet. So the liver likes consistency. These cytochrome P450 enzymes are needed for things you ingest or make daily, and they'll be ready for you as long as the nutrients are present. And liver also uses stored nutrients for phase 2, but you can only store about 3 days worth of nutrients in the liver. So if you're not constantly putting new nutrients into the body, it could have a problem as well. In terms of detoxing, remember all nutrients pass through the liver, and in theory, they may be used for detoxification. If a person doesn't consume enough nutrients, then choices have to be made. Storing of toxins or excess hormones in fat cells is an option, and if there is neither enough nutrients nor energy, which of course comes from carbohydrates, for detoxification, they may not be removed. All right, so the thyroid. It's a butterfly-shaped gland at the base of the neck in front of the throat. It has 2 lobes, one on either side of the windpipe, and it's connected by the isthmus. And it makes the hormone triodoxyrenin, which I have trouble saying, which is T3, about 20%, and thyroxin, which is T4. So 80% of what it makes is T4, not T3. It also makes calcitonin, which helps regulate calcium, potassium, and phosphate levels by opposing the action of the parathyroid gland. The rest of the T4 to T3 conversion is done elsewhere, as I mentioned before. So the hypothalamus releases TRH, or thyrotropin releasing hormone, to tell the pituitary to release TSH, thyroid stimulating hormone, which in turn stimulates the thyroid to produce hormones. So this is known as the HPT axis. Hypothalamus, pituitary, thyroid. Once the thyroid has been stimulated, the thyroid has the power to control the production of thyroid hormones. There's also a negative feedback loop. The thyroid controls the production of the thyroid hormones by signaling the hypothalamus to stop releasing TRH. So you can see it in the diagram here. So first the hypothalamus tells the pituitary to tell the thyroid to start making the hormones, and then the thyroid tells the hypothalamus to tell the pituitary to stop making it. This is true for the HPA axis, which we'll talk about with the adrenals, and the HPG axis, which is hypothalamus, pituitary, and gonads, when we talk about reproductive hormones. So what's the role of the thyroid? T3 affects almost every physiological function in the body. T3 is 4 times as powerful as T4. So when you're measuring thyroid function, it's important to know what T3 is more than it is T4. Every cell in our body relies on thyroid hormones for its metabolism. And the thyroid uptakes iodine into the cells of the thyroid, and together with tyrosine produces T4 and T3. Zinc and selenium are essential for the uptake of iodine. This is why it's not a good idea to ever take iodine by itself. You should always make sure zinc and selenium are present, and whether this is by consuming something like sea vegetables, which will have all 3 present, or you have a multivitamin that you take when you take the iodine, all of those will work. Maybe a supplement will come with the iodine, the zinc, and the selenium, which would be good too. But for our purposes, we're not going to be focusing so much on trying to fix thyroid problems by looking at the thyroid alone. This is why the hormone interconnections are important and why these players are important, because I've never seen a thyroid fix itself with iodine, zinc, and selenium by itself. So what are the functions of the thyroid? Increases metabolic rate by increasing the mitochondria activity for energy production. The mitochondria uses oxygen and calories from foods to produce CO2, water, heat, and energy. It maintains body temperature. It stimulates protein synthesis. And it increases the use of glucose and the breakdown of fats for energy production. It also enhances the conversion of cholesterol into bile acids and affects the growth of nerve tissue, which can in turn affect mood, memory, and cognitive thinking. It can also affect stomach acid production, digestive and intestinal motility, and intestinal permeability. So right there, just talking about the thyroid alone, you see several interconnections with some of the other players that we are going to look at. The pancreas has both exocrine and endocrine function. Its exocrine function is where it is due to it producing pancreatic enzymes that we use for digestion. It's essential for providing nutrients to make hormones, and of course, to make hormones you need protein, fatty acids, and of course the energy to produce them, which is coming from carbohydrates. Pancreas also produces bicarbonate to neutralize stomach acids in the duodenum. So when your food materials that are mixed with a stomach acid move into the duodenum, they need to be neutralized. And it's the bicarbonate that does this. And then once the material from the stomach now has a alkaline pH, the enzymes from the pancreas will work because they work in an alkaline environment. They don't work in an acid environment. So neutralizing stomach acids when substances enter into the duodenum is very important. Now the endocrine function is that it produces 3 hormones. One, of course, is insulin, which helps get glucose into the cells from the blood and lowers it in the blood. Glucagon raises blood sugar when it's low by working with the liver to convert glycogen to glucose. and somatostatin, which helps to control the release of other hormones. Now, you may not be familiar with somatostatin, so just a little more information about it. So it's made in several areas of the body, but primarily the digestive system and the nervous system. It's also known as growth hormone inhibitory hormone, and regulates hormones in a number of areas of the body by preventing the production of too many. So the pancreas also prevents too much insulin and glucagon as well. So there's regulatory activities going on in the pancreas for the hormones it produces. Now these also regulate the hypothalamus signaling and in turn pituitary function, including growth hormone and thyroid stimulating hormone. So this is important because, you know, we talk about the HPT axis and the HPA axis and the HPG axis, but here we have the pancreas having an effect on the hypothalamus, which of course is at the start of all those different axes. So this is what I mean. You can't really separate these things out. You have to make sure they all function well. In terms of the GI tract, somatostatin reduces gastric secretions and the emission of gastrointestinal hormones such as secretin and gastrin. And because it balances hormones, an issue can cause other hormone problems. Low levels can be associated with problems linked to high levels of other hormones like growth hormones. This is rare, but high levels can be associated with a somatostatin tumor, which will produce somatostatin independently, causing the suppression of other hormones like insulin. Now, in terms of the digestive system, both the liver and the pancreas are involved in the digestion process, as are gut bacteria. And digestion is critical to having healthy hormones, as this allows the body to be supplied with the nutrients it needs. The digestive system has 5 hormones. Gastrin, which stimulates the gastric glands to secrete pepsinogen and hydrochloric acid into the stomach. It is stimulated by the arrival of food in the stomach. Secretin signals the release of sodium bicarbonate in the pancreas and bile in the liver. Cholecytokinin, or CCK, stimulates the release of digestive enzymes in the pancreas and the release of bile from the gallbladder into the duodenum. Gastric inhibitory peptide, or GIP, decreases stomach churning to slow the emptying of the stomach. And finally, motilin is involved with gastrointestinal motility and stimulates the production of pepsin. So that's a lot of stuff going on, a lot of chemistry and a lot of hormones just to help us digest our food. There are 2 other important hormones I'm just going to mention here. One is ghrelin, which increases the appetite and is produced in cells that line the pancreas in the stomach. Leptin increases feelings of satiety, produced in fat cells, and signals the hypothalamus. And leptin and ghrelin levels increase in the saliva when you chew. And one more reason why chewing is a really important aspect, even with hormone health. There's so many things that chewing can do that will be helpful for how the client functions and how they balance hormones.